Okay, and I'm gonna start again. Okay, so then we see that the environment is well affected, and we humans have a great impact on the local environment and also the global environment, which is the interesting thing about this. It's local and global. So I'm going to talk today about direct and indirect impacts of the environment, and also about marine pollution. And two members of you are going to talk about on some pollution. One of the direct impact. One's going to be on corals. The other one's going to be on marine pollution, and specifically on thermal stress and thermal pollution. And just to show what kind of examples people are looking at when they talk about these kind of ideas. It's very direct, it's quite simple, and there's not too many catches to this. And it's basically a list of what you probably know, but know just a little bit more than the usual. All right. So I'm going to address direct impacts. And direct impacts, I'm going to start with something big, and then slowly go something closer to local impacts. So I'm going to start with overfishing. We talked about fishing and overfishing before, but I want to give you another insight onto it. Same thing about invasive species. Look about the angle, which about the ecological angle, and how the impact is impacting the environment. I'm just going to give you some examples of how humans are impacting invasive species and overfishing. So some is going to be repetitive, but just an extra. And obviously the dam construction is always the same. This is a paper that did a model on here goes another model. So it's quite complicated to understand the model, but basically they came up with various ideas of what's the two major impacts that humans have, or general things that happen to fish. And they realized that the chlorophyll in the water, the amount of chlorophyll, which means basically how much primary production there is in the water, is very important to the amount of fish. You can see here the biomass of fish, and it increases as the nutrients increase. And you can see also on the other side, as you can see here, the presence of humans also reduces the amount of abundance, the abundance and the biomass of the fish. Here's the biomass, so it reduces the biomass of the fish, usually also the abundance. The paper actually did the modeling and tried to do this in two places. You compare it to areas which are remotely inhabited, just small islands in the middle of the Pacific, and areas which are well populated. And they did it to various organisms and checked out how it impacts various organisms. But I want you to look at the general picture, not the details. The general picture is like this. You can see here in areas, in remote inhabited areas, that humans are not affecting, because you see the humans are the gray. So you can see that humans are pretty much the same. And actually, what's actually depleting is the decreasing in the amount of chlorophyll. That's what they found, the major differences between the various islands. So this is exactly what they found before. If there's more chlorophyll, there's going to be more biomass, fish biomass. There's less, it's going to be less. The interesting thing about this is in populated areas, when you look at it, you can see that if there was, what happens in general, and these are areas where you can see an increasing amount of humans, and this is the model which is presenting what would happen if there was potentially relatively a higher number of people. And you can see the amount of presence of people is first of all going down. The increasing in the humans is going down, but the amount of populated areas, if there's going to be a populated area, it will be staying the same. So the idea is that humans reduce the amount of an abundance of fish is presented. I want to tell you another thing about overfishing. This is a funny one. Take a look at this one. And I'm probably going to show it to you also in a different place, in a different context. Now look at the cartoon and tell me what you think about the cartoon. All those who eat. You can write down, I'm gonna. Tell me what you think about the cartoon.
I think maybe it says something also about overconsumption and distribution of food. Like it used to be like, and like in two ways that also because there used to be more fish, and people were in, like consuming less, so and it was whatever they caught was distributed better.
Okay. So
I think it's sorry.
Yeah. Go on.
No, I think it's just exploitation of our environment and how we are taking much more than we really need.
Well, this is exactly what I want to show you. There's two ways of looking at it. And I decided to, I think the common way of looking at it is what you just said. There's, Amy said, fat man, small fish, big fish, small man. And it's exactly like what it's actually telling us. But the hidden story about this is obviously what's happening. In the old time, it used to be less overexploitation and the fish were bigger. And now there's less fish, but humans are bigger. And the question is, what happens about this? Obviously about what you just said about fishing in general, about the way people are living and their lifestyle. But I want to talk about the lifestyle in general and explain something else, is what happens if I cut this half in the middle, and I'm not going to tell you this or that. If 1959 was not existing, and I would see just this picture by itself, I would imagine this is a small fish or a big fish.
A big fish?
Yeah, big one.
A big fish, probably a big fish. And this tells another story which I want to tell you about. This is called the shifting baseline syndrome. One of the things which are important for overfishing is that it's relative. And that's the idea of what I was thinking here, is about the relativity, about the size of the person and the size of the fish. And it's relative in the essence that what we think about is about overfishing, if it's true or not, is usually dependent on the baseline that we have. If this is the baseline or this is the baseline, it depends on the behavior and the actions that we, first of all, on the results, and also on the behavior that how we're going to treat the answers that we have. So that was introduced by Daniel Pauly, and eventually said that scientists that actually learn about these things, it's all relative to what they started when they started their career, basically. So fishery science accept as a baseline the stock size and species composition that occurred at the beginning of their career, and uses this to validate the changes. So we don't really know what happened a long time ago, especially if we haven't been born in 1959 and were conscious at the time. And what we need is good baselines to make a good assumptions of what's going on, and also to understand that there's a limitation in what we can do and how we look at things. So this is another way of doing this. This is 2000. This is before 2300 before BC. Eyes got away, but look at that full fish. And 2000 before BC, pyramid done. Let's feed and catch fish. There are many fish. 1906, the city may be in ruins, but we still got fish. 2006, well, we got our limit, and it only took us 3 days. All right. And they're all happy. The idea about this is they're all happy. This is the thing about it. We're all happy. And the question that the question is, are we good? Are we bad? What's going on? What's going on with the conditions? So I'm going to show you, this is an experiment done in Australia. And you can see here, and this is a cool experiment. And they wanted to see what's the difference in the environment if we change the amount of fish which are herbivorous fish. Herbivorous meaning eating the algae. And how they did it, they put the plots, they basically cages, big cages they did there. And they checked out the algal cover in an area which was caged, meaning you cannot have fish inside. And partial cages, meaning cages with openings. And open plots, which just basically a line on the floor, same size, and they can come and check out what's going on, count the number of fish, and the number of the amount of algae. And you can see, here that in places which were caged, the number of the algae cover was quite high. From the beginning, when they started in the beginning, everything was the same, and then there's an increase in the amount of algae. Why? What's the question?
The fish can't eat it because they're trapped, so they can't move around to eat it.
Right, exactly. So there's no fish coming inside, so it just grows wild, and you have lots of algae growing in this area because there's no algae eating fish. So this is interesting, and you can see here what happened as well. I want you to see this. Here is it? This is an increase in coral cover. This is in Australia, remember? And what happens here is you can see the increase in coral cover in where it's caged was lower than places which were not caged. Can you explain this to me now? It's very similar. Guys, those who are eating, I want you to come come with us and be part of the lecture, please.
Isn't there a symbiotic relationship between the fish and the coral?
Well, this is exactly what I want to discern. So look what happened. There's no algae eating fish. Then there's in that area when there's caged, there's lots of coral, lots of algae. But what happened? Accordingly, there's less corals. So basically, algae and corals are changing. Either it's going to be an algae environment or a coral environment. So there's an increase there is decrease in corals. There's a competition between the two, usually for space. And you can see what happens here. This is the number of recruits of corals. In a caged area, there's very few corals that actually make it and start anew. In the partial cages, it's much better. And in the open plots, even better than that. So basically what it says is if you have open spaces where fish, especially eating, in this case, algae eating fish, are around, the amount of new corals that are able to settle down and restart their life is higher than the place where there's none of them. So this is an impact on the local environment. This is how the ecosystem is changed. And you can see the amount of corals alive is also decreasing in places when they're caged. So there's a competition between algae and corals. And those who are actually controlling the amount of algae is the fish. And what happens if you do overfishing and I fish those fish that are algae eating fish, I'm changing the local environment. That could be of great sense. It could be really, really dramatic because I can change the environment from a coral-dominated environment to an algae-dominated environment. Basically what we call a phase shift. Change one ecosystem to another. This could be either this or that, depending on different variables. So I want you to check this out. This is a concept of a phase shift. And if I have a community and there's stressors, the stressors, theoretically, this is the optimum here on the bottom. And stressors always want to move it to one side or another. So it's going to be going this way and that way, this way and that way. But eventually, you will pretty much move around a stable area. If I have a change, the change what it can do, it can change basically the height of the barrier that I have. And if I change the height, it can be maybe a little less high or change, it can change a little bit. It could go from here and drop to a new state of stability. Now it stays over here. Meaning if I was here, for instance, this was a coral environment, I can switch to an algae-dominated environment. So we would say, okay, so what's the big deal? If I'm gonna do that, I'm gonna just go back. I can take this and go in reverse. The problem is, what we call hysteresis, the amount and the conditions to go from one side is not similar to going in reverse. Meaning that in nature, we don't have direct way of reversing. So basically, hysteresis, it's a discontinuous regime of shift, a phenomenon for which the return path from altered to original state can be drastically different from that leading to the altered state. So if I was having this threshold, this is the ecosystem state. I was in one state, and then if the threshold is high, I'm going to slip and go to a new state. Basically, I mean this state over here and then the state over here. And the differences between going from one place to another is the physical or trophic stressors. So you'd say, let's go back. So let's go back on this line. If I go back on this line, I'm going to go back and hit it over here. But it's not the same, because when you go in here, you're going to have different points for crossing from one place to going back. So that makes a big difference. It's almost impossible to go from one phase shift back to the original phase shift. This is a theory, just to understand, this is a theory. So people are very afraid from a change from a shift from one phase of the environment to a different one. And that's one of the biggest threats that we have with overfishing. So maybe the recovery needs to be more extensive here, for instance, to return to the original state than it was before. We need extra than we had before. Not just going up, we need something else. All right. I'm going to go a little bit about invasive species or not. I think I'm probably going to skip that. I'll just do a little bit of this. The idea about species, invasive species, is the change in the environment. We talked about before. There's there's impact on species. There's impact on the ecosystem engineers, which we talked about. There's impact on the ecosystem in general, their processes and their functions. And probably this is probably the gravest and most important thing overall. And I want just to look at here and how it changes, and obviously what you can choose basically will cause eventually ecosystem instability. So the good part about this is that it creates a new, if you have an invasive species, it will change there's going to be increasing filter feeders in new habitats. Everything's going to be changed. And theoretically, if I'm opening new niches, I can advance forward. The downside of it is we're going to see the destruction of novel places, areas with anoxia, filter feeding. Also, it could be either good or bad, overgrazing. All these things could be of great impact on the environment. And you can see the list basically of the goods and bad. It's more bad than good in general. This is or Jivan, or talk to you about. He taught you, haven't he? Silence.
Yeah, or told us.
Yeah. Okay. So this is a paper that he actually produced in 2014, and he talked about the invasive species in the Mediterranean Sea. And this is what I talked to you about before. We saw there was a change between local to indigenous, from local to indigenous. From indigenous to invasive species in the Israeli area, and you can see that the abundance of them has changed dramatically, and their density. But there's a lot of a lot of indigenous species living in relatively small frame, and now there's change because of the non-indigenous environment has been of non-indigenous fish have created different niches, and their abundance has increased dramatically, more than the indigenous fishes had before. So the density has changed dramatically. I want to show you this before, and here is what we talked about before. He checked about competition and the effect of fishing, and also the surface sea temperature. And you can see and this is obviously from climate change. And you can see here, this is the effect of abundance. And the marine says, I'm sorry, I'm going to look at this. I'm not going to go forward about this one. And what he said, he put it on a rating of some sort of importance. And he realized by his things that competition is important, but not very important. And fishing as well. And according to his realization and his modeling, he found that climate change is probably the biggest change that changes the amount of fishing. The amount of invasive species. It's really interesting because that means that on a global scale, we're changing, and this is what you said before, we're changing the opportunities of invasive species to become more resilient to climate change, and therefore they're going to be more prevalent. And I don't know if you're aware, but the Mediterranean Sea has increased in about 1 degree per decade Celsius. And that's a very quick and dramatic change that we have in the water of the Mediterranean Sea. Let's skip this. And we talked about dam construction. I want to show you something about dam construction, how it changes the local environment on a local scale. And this is the Aswan River, the Aswan Dam, sorry. And this is from the Nile. And you can see here, this is the amount of phosphorus nutrients before the dam and after the dam. What happened, you can see that basically the nutrients has been stopped almost completely. If you look here and you can see, this is the fisheries landings. You can see this is before the dam, and then after it was built, you can see it drop and stayed relatively low until there's been a slow increase. It's interesting because the fact that what happened here is that the amount of nutrients has reduced. Since the amount of nutrients has reduced, that means that the amount of nutrients are the base of the food chain, because phytoplankton use them, and phytoplankton are primary producers. And according to that, all the fish, the food web has basically collapsed and decreased. Now, it took some time for the nutrients to reach newer level, meaning it's coming from different sources, other sources. And then the community has increased back to normal, and even more because then they were fishing better. All right, let's see what you can do. All various local and things that can happen, how we can hurt the environment. You can see coal mining. Doesn't happen very often nowadays, especially in the Asian. Still, you can see in some places which are very primitive. And you can see how they're mining and using it for building materials. Obviously dramatic. Coastal development, I want to give some attention to coastal development. In 1 second. And you can see the important about coastal development is that most people would like to live very close to the beaches, very close to the sea. And the thing is that these areas have special importance. You can see mangroves and wetlands, and you can see here here especially this is mangroves this area, this wetlands here and here probably. You can't see really in the pictures. And also a change in the dunes right next to the beaches. There's usually a small dune that happens next to the beaches because of the waves. And humans like to change these things, and when they do that, there's an impact on the environment. So there's a contradiction about this. I want to show you this example of what happens if there is a mangrove area not too far away from a reef, and a place where they compare it to a place where it's either mangrove rich, which is close to a reef, and where there's no mangroves, meaning mangrove scarce system. The importance about mangroves, and you talked about Wadudi, is they're basically a nursery ground for a lot of fish, the young fish. And actually, the seagrass is also doing the same thing. Most fish, what they do, and I want you to look at the mangrove ridge and go from here to here. The young ones, you can see they're small ones, and this is for this species, live in seagrasses. Basically, what they do is they hatch over here. And then they move to the mangrove area, because you can see here their size are growing bigger, then going to a patch reef, and eventually to the fore reef, which is the bigger reef out closer to the open area. In an area which you have a mangrove, where there's no mangroves, the seagrasses are the same, the size about the same. When you go to patch reef, because there's no mangroves at all, you can see an increase in their sizes, and also an increase in the fore reef. This is actually about the same, but patch reefs are increasing. Basically, there's a jump from here to here. The question is, by size, you can see differences, but not huge differences. But what you can see about this is that what happens to, this is another way of showing it. Sorry, 1 second. חמודים, אני באמצע שיעור, אני מבקש לצאת החוצה. אני לא יכול, אתם מפריעים לי. I'm sorry. Corona time. Okay. All right. They were supposed to not be here. So here we go. First place, where the mangroves are appearing. They're born in here in the seagrasses. They go to the mangroves and they grow bigger. They go to a patch reef, shallow reef, and eventually to the fore reef. When there's no mangroves, they start the way here in the seagrasses. They go to the patch reef, shallow reef, and fore reef. The thing about this is not only the size is a little different, is when you look about the biomass, you can see huge difference in the biomass. And you can see here the patch, shallow, and the open reef, fore reef, and just the same one. This is the Scritus, this species. You can see here in the difference between the scarce and the scarce mangrove and rich mangrove environment, where they're coming from. There's an increase in the biomass of about over 2,500, only 2,500. Also happens in the shallow reef, also in the Montastria reef, which is the fore reef. So basically there's an increase, huge increase in the amount of biodiversity. So what it actually entails that the size may be about the same, but the amount of fish, their abundance eventually in overall biomass, increases dramatically. So there's something happening. If you have a mangrove area, it will cause it to have much more fish in the local coral environment. Now think about it. If you're destroying mangroves, you're going to reduce the amount of fish. This is one of the better examples of why to conserve these mangroves. All right, let's go to direct effects. And direct effects are usually talk about humans in the water, direct human impacts. So coral breakage, probably the biggest thing we can find, especially here in Eilat. You can see people stumbling and talking and walking on coral reefs, and you can see huge coral breakage. I'm not going to talk about this because Daniela is going to talk about this, right?
Yeah.
Okay, so I'm going to try and give you control. If I'm not able, just let me know how to do this.
Should I share screen now?
I have no idea.
Yeah.
Yeah, try to share a screen. Hopefully it will work.
Okay, one sec.
I'm going to stop sharing.
Yeah. Okay, can you all see my screen?
I can see.
Great. So I'm gonna be talking about the effects of thermal pollution on benthic foraminiferal assemblages.
No, so Daniela, you're not the one. I'm wrong one. I'm the wrong one. So
No,
the coral breakage.
Bacteria?
Yeah.
Yes.
I'm sorry.
Okay.
I wasn't sure. That's why I asked with the question mark.
It also talks about that though.
No, it talks about different thing. I'm gonna keep you for later. Don't worry about this.
Okay, no problem.
Relax. It's okay.
How do I stop sharing? Here.
Okay. So Eukarya, you're on.
Sorry,
Sorry.
Eukarya.
It's okay. Can you see my screen?
No, you need to press share screen, right, Danielle?
Okay. Hold on a second.
Should be a green button.
Yeah. Is it? Can you see my screen now?
Yeah, I think in a second it will happen. Here we go. You see me? Yeah. Okay.
Okay. So you can see the screen now.
I think so, yeah. Or just, you need to open your presentation.
Can you see the presentation now?
No, not yet. You carry a press new share on the bottom and pick the screen that has your presentation on it.
Yeah, that's what I did. I don't know why it's not working. Okay, let me try again.
Yeah, when you press share screen, choose the option of the presentation. You get like a few grades.
Okay. Is that working now?
Oh no, that's me.
Yeah, that's working
but
now.
I think
yeah, we see now.
You see now?
Yeah, open your presentation.
I did. I opened it.
Yeah, and make it larger, and then it will be fine. Make it larger, and then it will be fine.
Okay. Is it okay now?
Yes.
Is it large?
Yes.
Okay. So the paper I reviewed is about the impact of intensive recreational diving on coral reefs. So the aim of the study was to determine the impact of diving tourism on coral reefs. And in order to do this, the study assessed the correlation between coral damage and the pattern of dive frequency, as well as the divers' behavior. So, yeah. So, according to the study, ILATs experience diving activities with over 250,000 divers per year, and it's pretty intense. It's pretty intensive activities going on every year in ILAT, and also previous study found that the reef site, several reef sites in ILAT is more degraded compared to other reef sites like Egypt, Australia, and other parts of the world. In order to do this, first I need to one of the main reasons why reef sites in ILAT are more degraded is because of the access to coral reef sites. It's a very easy access to coral reef sites, and mostly in the remote areas. So, in January 1997. So in order to determine whether this diving activities have an effect on the coral reefs, and a study was carried out between January to May 1997, and 251 divers' behavior was examined in 12 reef sites in ILAT, and these are the reef sites. So 193 number of the divers were mostly independent divers. 53 were guided certified divers, but then certified divers were kind of like excluded, because they are not being recorded in the logbook. So to determine whether topography has an effect on, because based on previous study, the previous assumption, sorry, they think that different topography level might have an effect on the damage to coral reefs. So in order to determine whether this assumption is true, the 6 types of diverse behavior, 7 sites of coral reef sites were selected, and these sites, they have like similar reef topography, and the diverse behavior were examined for 10 minutes, and then it was recorded that 6 types of diverse behavior to coral reefs were observed, and these are the behaviors. That's the hand contact. This is the lowest of what was recorded, the hand contact, and then from lowest you have the highest, which was the raising of sediments. So after the examination, it was recorded that for the 7 sites, reef sites, there was there was no significant difference whether this level of topography was different in different topography level. There was no significant difference, as the topography after the analysis, it was recorded that the significance difference was equal to 0.85, which means that there was no significant difference in different topography level. So in order to determine the impact of diving activities on the human impact, in order to determine the human impact on coral reefs, 4 sites were selected, and these sites were defined based on the level of use, which ranges from low use sites, medium to low use sites. And each of the sites, for the low use site, we have like, I think 495 divers for 3 months, within 3 months. So each of the sites we examined for 3 months with different amounts of number of divers. So the high use sites for 3 months, they recorded about 4,088 divers. So there were 2 types of damages to coral reefs that was recorded. These are skeletal breakage and tissue abrasion. And skeletal breakage is also known as the fracture hard skeleton. And for tissue, it's also known as the damage that exposes the underlying intact of coral skeleton. So in order to determine whether this type of damage was caused by human, there was an evidence of fabric threads and paint scraping on the coral branches. And in order to distinguish this from other damage caused by aquatic habitats, these fabric threads were collected and observed. So the study found that 65 in the low use sites, in 1969, the coral cover was 69%, and then compared to 1996, which has 67%. That means that there is little damage caused on the coral covers. Like the coral covers are kind of remain the same, almost the same, I guess, within this year. And in the low use site, we have 4,000 divers per year. However, in the damage rate for the high use site was twice as high on the average, but the study concluded that coral covers alone does not determine the unsustainable behavior of recreational activity. So based on this, what the study concluded is that coral breakage, and other damages to coral reefs can also should also be considered, not just the amount of coral cover. So the recommendation in the article was that 5,000 to 6,000 guided divers per year should be recommended as the carrying capacity for each site in Eilat. That's based on the findings. Also, environmental awareness, probably in form of a short briefing before the diving activities, so it's like enlightening people more about the damages to coral reefs, and also excluding untrained divers, and also those in the learning first course, let's say the first stage of learning, in diving, yes. So excluding these people from the vulnerable reef areas could help to reduce damage to coral reefs. And also, if it's possible to divert pressure away from overloaded natural coral reefs, so probably artificial areas. All this could probably help to reduce the damages to coral reef sites. Yeah, so that's it. So it's very short.
Okay, thank you very much. Questions? Guys, don't disconnect yet. Any questions here, Eukarya? Okay, I have a question, and it's a general question for all of you. Eukarya mentioned that one of the recommendations was to have 5,000 to, I don't know, 7,000 divers per year per site. And
5,000.
Okay. And first of all, how do you think they come with this such number? That's one thing. And the second thing, do you think that the recommendation has been implemented? Because the paper is from the beginning, it's like 17 years old or so.
I don't know, I think it's based on like I said, in the low use sites, they have like 4,000 divers per year. So, and there was low damage done to coral reefs in that area. There was low degradation rate. So I think that's the reason why they recommended 5,000 to 6,000 as the carrying capacity. And I don't think anything has been done yet because of the previous field trip presentation, field trip course presentation we had, and we still hear of the damages to coral reefs. And yeah.
Yeah, you're absolutely right. So the numbers are pretty much the same, hasn't changed much in the last few years. The interesting thing about this is that if you look in the last almost 15 years on the condition of the reefs in Eilat, you don't see a major decrease in the coral cover, although it's relatively highly used by divers way beyond what they think is the carrying capacity. So it's very questionable that these numbers are just made up and not really, not very true to what actually happens in the field. So it's an interesting point to think about, and it's true. I mean, it's really good recommendations. Almost none of them has been implemented, and usually because it's involving humans and people don't like to give away what they want. They just want to go and dive and do whatever they want. And it's very sad that this is actually what's happening. It's not worldwide, but this is common to see what it is. Great things that's been done. Very little scientific data, but very much not too much happening when you talk about implementing it. By the way, this is one of the first papers to introduce numbers of coral breakage. This is what I chose to show to you. Because up to then, it just said, oh yeah, the more people there are, the more breakage there's going to be. And nobody actually counted how much it is or how much severity of it. And you can see it's quite major. Okay, let's continue. If I can do that, hopefully. All right. So we're continuing. So coral breakage, and you talked about this. And let's do some others. There's also what we think about coral fishing. Fish feeding, simple stuff. People fish all the time, give fish all the time things to eat. Very quick question: why is it not good? Think about what he talked about functional groups in fish. What are they supposed to do?
It disturbs the environment because it will not eat other things. So it will have an impact on the whole food chain or the food web.
This is exactly it, Rebecca. Right on the money. This is exactly it. We're afraid of them starting to be dependent on humans and changing the local, their function in the environment and then changing the environment. Wonderful, great. All right, soil raising, I'm just gonna do quickly. Divers like to do soil raising as well. It's mentioned in the Caria's paper as well. And it was one of the major things that's happening there. The problem with that, especially in corals, that you can see here, this is a live area of coral with live tissue. But all of this is dead. This is an experiment. And you can see what happens is when you have soil landing on the coral, the way for it to reduce it, because it doesn't have hands, and to remove it is produce a lot of mucus. The mucus basically comes out and slides to the side and eventually keeps the coral clean. The problem with that is that the coral uses a lot of energy to produce that. And if it happens frequently, eventually coral will not be able to sustain itself and it's going to die. So soil raising is for divers, mainly. Animal disturbances by touching, which basically means that the organism that will change its behavior. For instance, turtles will come to very close many times, not necessarily all the time, come to reproduce and lay eggs. If a female is looking for a place to a beach to go on to and nest, create a nest, she's eventually going to dump the eggs in the water. She's not going to come up and go to somewhere else. And obviously, the way to finish it and try to do this is underwater cleanups. You can see here, this is in the kids in Eilat doing some cleanups to clean the environment. It helps a little bit, and especially helps with awareness, which is probably the most important thing that you can think about. by humans and the direct impact of the environment. All right. Second part, pollution. Okay, this is a book. This is one of a very famous book for kids who do a potty training in Israel. It's called Sira Silim. And I want to show you the last page of this book. And I translate it for you and it says, goodbye poo, goodbye pee, said Naphtali. See at the sea, said I, Naphtali's mother, and I flushed the toilet. And I think this is about education. This is as far as it gets. We use obviously where it goes out eventually to the sea. And that's the idea. And it's very sad for me to think about it this way. And pollution by humans, almost all the pollution come by humans is usually man-made on land and then transferred to the sea. So there's various pollutions and various pollutants. And I'm going to skip what is pollution because you probably know, but the idea is basically any kind of waste that will will be of deleterious effect to the environment to a certain extent. And I'm going to be quickly going on it. You can read it later on. Same thing about marine. And basically, there's various three different ways of maybe categorizing pollution. One is mechanical, physical. The other one is eutrophication, meaning a lot of nutrients in the water, and toxicity. And mutagenics. Okay, so mutagenics. So these are the major players. I'm going to talk a little bit about all of them very quickly. And probably the physical, Danielle is going to talk about the physical. So I'm going to be talking a little bit about this, a little bit about that. So let's go quickly about this. Look at that. This is a list of various marine pollution causes or that can be happening. I'm going to go a little bit about them. Danielle is going to talk about thermal pollution. I'm going to go on probably the first 4 or 5 of them if we have time. And I'm going to start with the thing that you probably know is marine litter. Marine litter has been lately been very well publicized. Basically, it's any kind of solid material which is found in the water. And its impacts is obviously important. Could be a navigation hazard. If you have a boat and you have I don't know, a log in the water, which is not supposed to be there, it can be hazardous to the boat, can be damaging as well. So there's an economical impact to that as well. There's contamination to the beaches and harbors. You've probably seen the pictures. I'll show you a little bit as well. The changes in biodiversity and also physical damage. For instance, for corals, you can see direct damage to corals. Let's go a little bit about what it is basically. And you can see here that this is various marine litter materials. And all of it, 75%, is made out of plastic. It's a huge number. And just to have a comic relief, I'm going to put something on for fun. Do you want something fun? Yes or no?
Yes.
Yes, okay. Thank you. Sorry, screen. Okay. Sorry.
We can't, yeah.
You can't hear? Sorry. Okay. I thought it was, oh yeah, I forgot. It's, yeah, hold on. Okay.
Jungle. Home to many creatures great and small, and the popping ground for one of the most clever and illustrious creatures, the plastic bag. Today we explore the cycle of life for this curious creature, the plastic bag, on its migration to its home, the Pacific Ocean. Once released into the wild, the plastic bag is unsure of itself. It falters at first. But soon, with some help from the wind, the bag will be airborne. This flight will be the first in its long journey towards its final destination, the garbage patch in the heart of the Pacific Ocean. Using the wind to guide it, the plastic bag moves across the city through the air. A city park. This park may at first seem an idyllic place for the plastic bag, but danger lurks round every corner. Here it will encounter many enemies, including one of the most dangerous, park services. Poor little fellow. Looks like his journey ends here. Meanwhile, our little bag has encountered one of nature's most deadly killers, the teacup Yorkie. Once the Yorkie has locked onto its victim, there's very little hope of survival. But using its superior size and deft maneuvering, our bag manages to escape the Yorkie's talons and flee for its life. Over the course of its miraculous migration, the plastic bag will cover vast distances through neighborhoods, across parks, and down city streets. It is now nightfall, and our highly advanced night vision cameras have managed to capture for the first time in history a plastic bag in pitch black. Phenomenal. The vast cement rivers of California, home to literally dozens of animals. Many plastic bags will not make it out of here. The reeds and branches will see to that. As at home in water as it is on land or in the air, the bag's natural buoyancy makes it an excellent swimmer. It's close now, and it can feel it. At last, the bag has reached the gateway to the open sea. Careful to avoid the mouths of hungry sea life that feed on the helpless plastic, the bag will travel hundreds of miles to join the thriving community of plastic known as the Great Pacific Garbage Patch. The Garbage Patch is a veritable plastic oasis where millions of tons of plastic garbage remain trapped by the currents. It is said to be twice the size of Texas. Never actually biodegrading, here the plastic bag can live indefinitely, peacefully coexisting with billions of other petroleum species before breaking into ever tinier plastic pieces, thus completing the plastic cycle of life.
Okay, hope you had fun. But it is kind of funny, but it tells a big story. And hold on, this is not the right one. Let's go forward anyhow. But it tells the story of plastic in the oceans. And it's very unfortunate. Hold on. Okay. So I'm not going to talk too much about this. I'm going to cut this short because we're not going to have time. And you all know about plastics and the microplastics, correct? Okay, because I understood about this before. It became a big deal about macroplastics, especially that microplastics have its way. First of all, it produces PCBs, which is a mutagenic material, and it bioaccumulates within the environment. And we know this. Almost all the organisms carry some kind of some kind of plastics to it. And obviously, Carolyn, yeah, you all know about plastics. So it's quite dangerous. Well, actually, this is like the last 10 years has been given attention. Before that, nobody actually cared about this. And you know, these lotions that they have, these tiny pellets, you probably heard about them as well for the lotion for the small beads, which are made of plastic and also washed to the ocean. All of these are found today if you go on the beaches. And unfortunately, they all go into to these big, what they call 5 gyres, which is basically big, like we saw in the big Pacific garbage bag, similar to that. It's big 5 different gyres where they all mix together. And it's only the microplastic that actually kind of float. Most of it actually finds its way to the bottom, and it can smother everything on the bottom. Let's look at some other material. This is we're going from physical to chemical materials. And here is TBTs, tributyl tin. And used to be a very important material to cover boats. See how they're painting boats on the bottom. And you can see the difference between having TBT and without the TBT. And what you can see here is the biofouling. This is exactly what we talked about before, the fouling of organisms that can hitchhike from one place to another. So you can think about it in a good way, which is a really good idea. Paint boats, so we're not going to have fouling on them. The problem is that how do they evade how these they survive here and not survive here, because this is toxic. And the problem with this is that TBTs has been found to be relatively quite toxic to many small organisms, and they can change dramatically. They can change them, and they can do some what they call imposex, for instance. It can change the female to producing male organs, and then interfering with their reproduction. And we found this also in the Mediterranean Sea. Here in Tel Aviv University, there's been an experiments done, and either by experimentation and also in the local environment, we see leftovers of TBTs. The good thing about TBTs is that they fall to the bottom, basically. They're relatively heavy, and you can find them usually in sediments. Most of them are relatively close to where they're actually been found, meaning usually ports or places like agriculture or aquaculture where they used to use them. Since they're very toxic, about now it's almost 10 years ago, they were banned, and today you're not allowed to use TBTs, but still you can see some people using them, just to let you know. And the way to deal with that, with the biofouling, using today more environmentally conscientious, I would say, paints. Usually silicone-based. It's very slippery, like Teflon, and things cannot get attached to it. The problem is that they're relatively expensive, and they don't stay. They don't. This was 2008, and they're and they don't. They're not very effective for a very long time. Other materials that we know that can leach to the environment dramatically by humans from land, most of it's from land, is mercury, copper, and cadmium. Cadmium is basically has been damped almost everywhere because it's very, very serious. So the source of most of these come from the industries, and then you can see basically what there is there's bioaccumulation of these materials in the food chain, and you can see if you have a small fish that eats and gets a little bit of contamination, then a big one eats it and it accumulates it. Eventually you get the bigger one and accumulates that, and eventually is going to eat the big one. We're going to eat the big one. So you can see that they have these things accumulating in nature. And so it becomes poisonous only if it's in high numbers, concentrations. And it has, for humans, if we have it, can also cause abnormalities, cancer, so a lot of them are mutagenic. In Japan, there's been poisons, huge poisonings happening because people are eating usually relatively big fish, which hasn't been checked. Let's see what's happening here. This is the Mediterranean Sea. You can see this is the pollution hotspots in the Mediterranean Sea. Basically, almost everywhere, a little bit of concentration in Turkey. They have a lot of industry very close to the beaches, to the coast. And you can see here, this is toxic persistent bioactive contaminants. Basically something which is usually, most of it is of biological origin. Here we can see in Israel, this is the Shafdan. And Shafdan is basically the sewage treatment plant very close to Tel Aviv. And it's still, as we speak, it's dumping butza, I forgot the name in English. after it's been cleaned, they dump the leftovers of the cleaning into the sea. There's a big pipe that goes in about a kilometer in, and it dumps it over there. Obviously, not very good for the environment. And you can see here, this is cadmium, copper, and mercury. And the thing about it comes to large industries, and largemouth comes in very close to rivers. If you can see here the rivers, you can see there's the entry of rivers in the big rivers that you have. Most of them are found in this area, and it coincides with, for instance, cadmium, which you can see here. Today, as I told you, cadmium is today is hardly ever used. They used to be having cadmium batteries. Everyone's changed to lithium batteries because of the poisonous. That cadmium is very poisonous. All right, I'm going to go to BP and talk about running. All right. So this is BP, and this is what I'm talking about, the pollution by oil spills. We don't have oil spills here in Eilat. Sorry, we don't have in the Mediterranean Sea. And what we need to see is that not that we don't have, it's we don't have yet. It's probably the best word to say it. And the first big oil spill was in by the Exxon Valdez. It was a big big ship that has been grounded, and lots of water has been contaminated accordingly. And it's an important thing because this is the first time that had had a global attention to an oil spill that never happened before. About 500,000 barrels. It was relatively big. And you can see here the environment has been, especially in coastlines, which had been all covered with the oil. Animals, you can see here sea otters have been, their skin has been damaged. You can see birds. I'm sure you've seen these pictures before. And the cleanup for these things is dramatic. The important thing about the Exxon Valdez, not that it was the first one to be so big and also get such a big coverage on TV, it's also the first time that the company had to pay damages for the cleanup for the local people. So it was the first time they ever used environmental I'm sorry, I'm a little bit out of it. It was the first time they actually realized how much money should be paid for environment. And this is the first time it's been used. And this is not the first time, not the only time, because there's been a number of oil spills. Probably the biggest one is the horizon. Sorry, the deep horizon. For that, I want to show you Exxon Valdez spill 25 years later, and you can see the recovering and species which have not recovered yet. You can see that a lot of the local, the intertidal has recovered relatively quickly because water has been cleaned up very quickly. Birds, you can see river otters, not sea otters. See them. Fish. And here you can see harbor seals and a lot of other birds, like cormorants, for instance. And the interesting thing about this is to see that, for instance, those organisms that are still not recovering is killer whales, herring, and some dolphins also still have remnants of the leftovers. BP is probably the biggest one that ever happened in this area in the world. It's got lots of attention. And it was in the Gulf of New Mexico. You can see the origin here, and the spillage was amazing. It was an oil spill, not from it was from an oil rig, and not from a vessel, and just kept going for about 2 months, something like that. So it was a well blowout, 87, almost 3 months, 87 days of spill. Compared to the 5,000 that I told you before, this is about 5 million barrels. It's very, very big. and the environment has been dramatically impacted. And you can see this is from a satellite imagery. You can see the spill from space. The impacts were quite grave for the local environment, and you can see various impacts like lesions. You can see here lesions that happened on fish. And you can see also here you can see the development of fish. This is by experiments using BPO concentrations and control. You can see that early stages, they have larvae of here, it's yellow fin tunas, but it's not the only one that has been damaged. You can see there's a deformation in it. So this one will not survive. This one, control, will survive. And you can see turtle beach expanding has been increased. Dolphin deaths have been increased. Deformities in fish larvae, like here. And birds, obviously, which is kind of classic. So the good thing about it, they had to pay quite a lot for these. They also had, by the way, the people used to do the cleanup also had problems like breathing, skin problems, and so forth. So it's a big deal. And they had to pay a lot for it to come out of it. So that's not the first time. It's the third or fourth time that people had to pay for it. Over about $40 billion just to pay for the cost. And I would tell you, they're still doing well, the BP. The question when will happen, what will happen to the next time? So these are various factors that can that are relative to pollutions. There's other pollutions which are relevant, like sound pollution, which is very relevant to cetaceans mostly, dolphins and whales, and is related to their beaching, and other things which are thermal stress, for instance. And for thermal stress, Daniela is going to talk. Okay, Daniela.
Yeah.
Okay.
So I'm gonna make it brief because I think we don't have a lot of time.
Yes, we have exactly the amount of time.
So I'm gonna talk about, can you see my screen?
I can see.
Okay, the effect of thermal pollution on benthic foraminiferal assemblages in the Mediterranean shore face adjacent to Hedera power plant. These are the authors. Ruti and Segal are from the Department of Geological Environmental Sciences in Ben-Gurion University. Aouba is from Geological Survey of Israel, and Barak from Israel Oceanographic and Limnological Research. So there's been a rise in temperature in our oceans of a rate of 0.2 degrees Celsius per decade over the past 44 years. And an increase of 1.28 degrees Celsius has been recorded in the Mediterranean Sea. This affects living organisms and geographical distributions and chemical reactions. This affects their growth rate, their reproduction, and in this presentation, specifically benthic foraminifera. Since the opening of the Suez Canal, there's been a large-scale migration from the Red Sea to the Mediterranean, including benthic foraminifera. These are unicellular organisms. They are the most diverse group of microscopic organisms with calcareous shell. They have a short reproductive cycle. They have fast growing rates, and they respond quickly to change. And because of all these characteristics, they are good candidates for studying the effects of anthropogenic pollution on marine organisms. The Hedera power plant it has a thermal pollution patch, and it has been open since the 80s. And this is why, for this study in particular, it has been used as a natural lab to evaluate the Mediterranean sea surface temperature's effect on benthic foraminifera. This is what is likely to happen in the Mediterranean Sea in the next decades. So how will the study's question is, how will warming of the oceans affect marine microorganisms? And this is like an example. So they've made 4 stations. You can see here is the Hedera power plant. Station number 1 is the closest to it, which represents the thermal pollution. And station number 4 represents the natural environment, a healthy environment. And you see station number 2 and number 3 in between. It's along 1.3 kilometers. And they did 10 monthly sampling campaigns, once a month for a year. Each sample had about 200 to 300 benthic foraminifera. Sorry, one of the things that they've been studying is like the main factors are temperature, abundance, diversity, and richness. Temperature is sea surface temperature. This is the environmental factor that changed the most throughout the study. Abundance was evaluated by the total number of individuals per gram sampled. Diversity took into account the sample size, which varied between the samples, especially in station number 1, where the sample sizes were smaller. We will look into that right now. And the richness, which is the sum of the species observed in each station. So here we see some results, and we can see that as I mentioned, the sea surface temperature is the factor that varied the most. You can see here, these are the months. And in the summer, the difference in temperature was lower between the stations than in the winter. And an increase from 1 to 2 degrees Celsius, like you see here in the abundance of the benthic foraminifera, you see that only a difference of 1 or 2 degrees Celsius can make a big change, like can create retarded growth in the microorganisms or even cease production. Foraminifera will grow and reproduce in a very narrow range of temperature. When we look at abundance, we can see that station 4, which is a regular situation with natural seasonal changes. And stations 1 through 3 have natural seasonal changes, but they also have thermal pollution. And we can see there's a considerably lower number of microorganisms, of benthic foraminifera. So station 3 is only 1.5 degrees Celsius above natural surface temperature. So a 1.5 degrees Celsius can make this huge difference. So we can see there's a threshold in temperature that can be only within 1 degree. There's a significant negative correlation between sea surface temperature and abundance. This represents diversity, and this represents richness of the species. And we can see there's a weak negative correlation when it comes to diversity. It fluctuated without a visual pattern. However, 80% of stations 1, 2, and 3 were made out of 2 or 3 species only. And when it comes to station 4, this was not the case. The highest number of species at the control station was in station number 4, and the lowest number of species was in station number 1, which was near the thermal pollution. And some explanations in these numbers, as Omer mentioned, was that some species might be more sensitive to sea surface temperature than others. And this is why we see some peaks and why maybe they were not affected. This is a conclusion that I came up with after your lesson. And it could be invasive species, some of the species that are less sensitive to the thermal pollution. Some conclusions are that stations differing significance. The station 4 was very different from the results of stations 1, 2, and 3. And stations 1, 2, and 3 did not differ significantly between each other. And these were the 3 stations that were very much affected by the thermal pollution. So we can see that the results are very clear and the effects are coming from the thermal pollution. Station 1, because of the pollution, some samples didn't even achieve the minimum requirement of amount of species, and they weren't able to sample them. This is in station number 1. The thermal pollution, as we said, has a very high and significant negative correlation to abundance. And the temperature threshold, as I mentioned, above 30 degrees Celsius, there's a drastic decrease in benthic foraminifera. So the threshold is even 1 degree. And this is a conclusion that I also came up with. Limiting global average temperature to below 2 degrees Celsius above pre-industrial levels, which is in line with the Paris Agreement, is the only chance for protecting the environment. And this is very clear, especially when we talk about the threshold. This is why I believe this entire study backs up the Paris Agreement of containing the 2 degrees, like not going above that. And I believe that if we continue as we are industrially, this is, we're not gonna be able to protect it. And I also think that some effects will be economic. And for example, the President of the United States decided to withdraw from the Paris Agreement because of economic growth. But he's not taking into account that this will cost a lot of economic damage if everything is not protected, and we all suffer the consequences. It's not just a pretty thing that is lost. And sorry, and now I want to ask you, I don't know if we have time, but what do you think can be done? Thank you.
You're welcome. If someone wants to give one more comment, and then we'll go off for the day.
Well, hopefully, like something significant can. I'm not sure. Like, I mean, I would think like some policy regulations could be put forward to limit that amount of change to those surrounding ecosystems. Because if it doesn't, I think what Dr. Omer said earlier in the class about the what was it called, the paradox of paradox pollution
of invasion.
Yeah, that. I think we would eventually, if we keep this up, I think we're going to slip into a position where we can't recover from the same way we got into it. So it is quite urgent that we need to do something.
Absolutely. Anyone else about pollution in general, human interference?
I guess, can you hear me?
Yeah.
So I think something that's important, I guess, tying in with everything, is that the effects of pollution are so dynamic, especially with marine systems, that it's posing not only like environmental degradation, but it's shifting range parameters. So it's allowing, like we were saying earlier, it's just giving more reasons and more potential for foreign invasive species, which tend to be generalists, to sort of embed themselves within more tight-knit communities and ecosystems. It's crazy how, you know, everything sort of has that relationship with one another, and yeah.
Okay, I totally agree, and I want to come maybe give a little thought before we go. Is that when I go to the ocean and I look at it, it always looks to me beautiful, nice, beautiful blue. But when you look at it in different eyes, maybe with the different glasses, you'll find out that it's not very blue, and it's very well contaminated, and there's a lot of stresses on the marine environment. And the most important thing, it affects us directly. So it used to be the dump, the pollution, bye-bye sea, the poo, go to the sea. And hopefully this will change, and And it's up to us to start administering this information, and taking care of the environment, not only the one that we see, but also the things we don't see, they're affecting us. All right. Guys, thank you very much. Have a great day, and recuperate.
Thank you. Bye.
Bye. Cheers. Thank you, Daniela. Thank you, Aquaria.